Hello, dear student. Today we are studying the digestion and precipitation from homogeneous solution. This is the part of thermogravimetry analysis. So let us see what is digestion. The digestion is the process of allowing the precipitate to stand for 10 to 24 hours at room temperature or by warming the precipitate for some time in contact with the liquid from which it was formed is called as oswald ripening or digestion. So during the digestion process, what happened, the process it gives the self purification of that precipitate, also increasing the filtering quality of the precipitate. Now let us see what are the exact changes occur during the digestion. The very small particle size which have a greater solubility than the larger one, it get increased by growing their size and thus reducing their solubility in the water. This also reduces the chances of co-precipitation. The rapidly formed crystals are of irregular shape and have the larger surface area. Next is the impurity generated due to the co-precipitation is not removed easily by simple washing. Therefore, to minimize the co-precipitation, we are using the digestion process. Let us see the application of digestion. Digestion provide a regular shaped particle and they are more dense. It helps in decreasing the surface area. Also, adsorption of the impurity get reduce the extent of co-precipitation. It gives the edge of filtration due to increase in particle size. Next, during the formation of precipitate, different type of conditions should be maintained in order to get the purified precipitate in a larger quantity. Let us see one by one which conditions should be maintained during the precipitate formation. In that, first one is the dilute solution. By considering the solubility of the precipitate, the time required for the filtration and subsequent operation should be carried out with the filtrate. This will minimize the error due to the co-precipitation. So, in order to reduce the co-precipitation, we are going to use the dilution process in the precipitation generation. Next is reagent should be added slowly. If we are added the reagent slowly, it will reduce the degree of supersaturation small and also grow the larger size particle. In short, to reducing the degree of supersaturation, we have to add the reagent slowly during precipitate formation. Next is hot solution. The hot solution increase the solubility of the precipitate. Also, at high temperature, solubility is increased, degree of supersaturation get decreases. Next is it favors the coagulation and sol formation get decreased, and the velocity of the crystallization is also increased while we are using the hot solution during precipitation. Next is digestion. You know very well that during digestion process, particle size get increases, filtration get increases. Also, it reduces the effect of co-precipitation as you see in the above topic. Then next is wash with the dilute solution of the appropriate electrolyte. If we are using the solution dilute and the appropriate electrolyte should be used, it may reduce the peptidization. If we are using general water, it gives the greater amount of peptidization of our precipitation. And the next is reprecipitation. Reprecipitation is nothing but the recrystallization. If the precipitate is contaminated as a result of co-precipitation or causes the error, it can dissolve the precipitate in the suitable solvent and then it is considered as a reprecipitating agent. It reduces the amount of impurity. This process you are already performed in FYBSc practical. Next is purification technique मध्ये. The next is low pH. If we are prepare our precipitate in low pH, it helps in giving the quantitative precipitation, means larger amount of quantity of precipitate get generated at the low pH. Let us see the precipitation from the homogeneous solution. Before starting this, why we are going to use the homogeneous solution for precipitation? Because gravimetric estimation are generally performed by adding the solution of the precipitant to a solution containing ion to be precipitated. Even with the rapid stirring, a relatively amount of supersaturation takes place. This leads to the formation of irregular shape of the particles, and also occluded impurity is present. Means what? When we are not using the homogeneous solution for the precipitation, what happen? There is larger amount of supersaturation is takes place, irregular shape of particle is takes place, and therefore occluded impurity get involved in our precipitate. This condition should be minimized when we are using precipitation from the homogeneous solution. Let us see what is homogeneous precipitation. The process by which the precipitate is formed within the solution is known as precipitation from homogeneous solution or homogeneous precipitation. Means external reagent should not be added. You have to create your precipitate or reagent within the same solution. Let us there are different type of example in your syllabus. That is, first one is hydroxides and basic salts, second one is the phosphate, third one is the oxalate, and fourth one is the sulfate. Let us see one by one hydroxides and the basic salt. For that purpose we are using urea is soluble in the water. Then it undergoes slow hydrolysis and shows the negligible basic property. These property are used to control the pH of the solution. By considering this, rate of hydrolysis is increases with the temperature. Thus, by keeping a definite temperature and definite pH at a given metal ion can be precipitated by the ammonia in its hydroxide or the basic salt. Sometimes the physical character of the precipitate can be improved by keeping the certain anion present in the solution. This process of precipitation of aluminium, that is aluminum hydroxide by urea hydrolysis, means what? In this particular example we are using the ammonia, urea and water, and urea and water create some amount of basic nature in that particular solution, and they provide a suitable environment for the precipitation of that particular compound. Here we are considering the example of barium as a barium chromate in presence of ammonium acetate, or nickel as a nickel dimethyl glycemate, or precipitate of aluminium as oxynate. This is all about the hydroxides and the basic salt. Next is phosphate. Insoluble phosphate may be precipitated by driving the phosphate ion by stepwise hydrolysis of trimethyl or triethyl phosphate. In this particular example, we are considering the trimethyl phosphate. This trimethyl phosphate is treated with water molecule. We are getting the methyl hydroxide, that is methanol, along with the phosphoric acid. For example, we are considering the zirconium is precipitated as the zirconium phosphate in the methyl phosphate media containing the sulfuric acid. Similarly, we can precipitate bismuth also as a bismuth phosphate using this particular method. Next, oxalate. Urea is used to increase the pH of the acid solution containing the bioxalate ion, thus slowly liberating the oxalate ion. Here what happened? Urea is treated with the bioxalate ion. We are getting the oxalate ion by maintaining their pH or increase their pH. Now, dimethyl or diethyl oxalate can also be treated, or they are used as an hydrolyzed to serve as a reagent for the oxalate. Means diethyl oxalate is treated with the water. We are getting the ethyl alcohol and 2 molecules of H plus ion along with the oxalate ion. This method can be used for calcium, can be precipitated as an calcium oxalate. Thorium can be precipitated as an thorium oxalate. So last one is the sulfate. In sulfate ion can be liberated by hydrolysis of sulfamic acid. The well-known sulfamic acid having the formula NH2SO3H is treated with the water molecule. You are getting the NH4 plus ion along with H plus ion and sulfate ion. By using this method, barium can be precipitated as an barium sulfate, and the hydrolysis of dimethyl sulfate also gives the sulfate ion. CH3 twice SO4 dimethyl sulfate is treated with the water molecule. You are getting the CH2 that is nothing but the methyl alcohol. So after getting the methyl alcohol, two molecules of hydrogen and sulfate ion, this method is used to precipitate the barium, calcium and lead as in their sulfate. So student, the last step, that is of sulfate, is already in your practical syllabus, that is generation of barium sulfate in a gravimetry analysis. So if you have any question related to this topic, you must be welcome in the discussion session. Thank you.